Section 16.2, vector fields and line integrals. So some learning goals here. You should know the meaning of vector fields and be able to sketch them. You should also know the interpretation of vector line integrals and be able to set them up and compute them. So last section, section 16.1, was about scalar line integrals. Now we're going to talk about vector line integrals. Before we get to saying what a vector line integral is, we need to talk about what is a vector field, because that's going to be part of the integrand for our vector line integrals. And so a little bit of means of motivation for what a vector field is. Let's just do a brief review of calculus up to this point. So in Calc 1 and also in Calc 2, we were mainly concerned with functions with, let's think about the number of inputs and the number of outputs that we have. So we can think of a one variable function like f of x is equal to x squared plus 7. This has one input, x. This has one output, x squared plus 7. But we're a multivariable calculus right now. So in chapter 13, we started to do vector valued functions. So something like r of t is equal to 3t plus 7 comma t squared. And so there's one input to these to this kind of function t, but then there's two outputs here, or three outputs. So we had a vector value function living in space. And let me point out, you could say, oh, but the output is just a single entity. This output is a vector here, and so perhaps a more mathematically precise way to say this is the input is a scalar, t, the output is a vector right here. And so then in our Calc 1 chart, we could say both of those are scalar input, scalar output. Now scalar input, vector output in chapter 13. In chapter 14, and then also in chapter 15, we're doing functions of multiple variables. Something like, f of xy is equal to x squared y plus e to the x times y. And so what's going on here? The input is, now we have two inputs, or we could have three inputs. If it was a function of three variables. But we have one output here, x squared y plus e to the xy. That's a single number. That's a scalar. And so in some sense, perhaps we could think of the input x comma y as being a vector input. We could rewrite this as a vector containing x and y here. And then the output here is a scalar. Okay, so input scalar, output scalar, input scalar, output vector, input vector, output scalar. What's missing from the chart? Well, guess what's happening now for a vector field is going to have a vector input and a vector output. Or you could think of it as having several, two or three inputs, or you could think of it as a different way, a different way to think about this could be that the input is a point in the plane or in space. So what does a vector field, what is, more a more precise version of a vector field? So vector field, it's a definition, a function that assigns a vector to each point in its domain. And so the domain is basically always going to be the 2D plane or 3D space. And so what is this going to look like? So f of x, y, z, so I'm doing something in the plane here, is equal to m times x, y, z, m of x, y, z plus I hat plus n of x, y, z, j hat plus p of x, y, z, k hat. And so an example of this would be f of x, y, z is equal to, I'm going to write it in this notation here, x squared y plus z, comma, z times e to the y plus x, x, y, z. And so this is our vector field. F of 1, 0, 1, just to show what's going on here, is that, let's see, plug in x is 1, y is 0, z is 1, 0 plus 1 is 1, 1 times e to the 0 is 1 plus 1 is 2, and 1 times 0 times 1 is 0. So what this is doing here is that the point in space 0, 1, 0, let's see here, 0, 1, 0, I think that should be right about there. The vector here is x, we're going at 1 in the x direction, 2 in the y direction, 0 in the z direction, so I think it's something like that here. So what's going on? We're associating with the point 1, 0, 1, the vector 1, 2, 0. You can think of it as there are 3 inputs here, 1, 0, 1, and the output here is 3 outputs, 1, 2, 0. We can think of it as putting in a point and outputting a vector. These are all kind of equivalent ways to think about it. This is a vector field. I should emphasize this is a vector field in 3-dimensional space. Of course, we could have f of x, y is m of x comma y times I hat plus n of x comma y times j hat. So an example of this, f of x, y could be x squared y plus 7 times I hat plus e to the x, y times j hat. So examples of vector fields. Okay, that's my introduction to vector fields. We'll talk more about them in the next video.